So now let me add here. So now let me check the size. Map dot size. So what is the output? Can you guess it over here?
Four.
Map, no, map. Map one.
Two. Then it would be two.
Two. So this is your two, right? Okay. So right now it's two. So let me say I'm adding the same key and same value. And now let me run it again. So what will be the size here? Will it be 2 or it will be 1?
1, right? Because hash code will be same and it will point to same array size or something like
that. So the values are same. You had ended up with 1 value. But let me do like this. So yesterday in employee, you created the employee object, student object, right, Kirba?
Oh, yes.
Okay. Can you create, okay, you can share the screen and do the same structure. I'll just copy paste it. You have to have your integer, like instead of integer, have your student object and you can have the string. Only thing that you need to change.
Okay.
You can share your screen instruction.
Sneha, the reason for one is it would be same hash code, so modulus will calculate the same index, right? So that's why we are getting as 1 as well. Right?
Yeah, but the main basic purpose behind that is to understand the contract of equals and hash code. So we'll see that in a minute.
Okay.
So in the same class, you can have your another object created, like whatever class you're using right now. You just create a map of student. Instead of integer, give a student, which you have already, and create a I already have reference, right? Okay. Now create. Go to your student class.
Yeah.
So create one parameters constructor with only ID. Yeah. So just replace line number 10 with int ID within that, and have this dot ID equal to ID. Okay. Now go down to your class, save this file. Now here, comment the hash code method. And the equals method, comment both the hash code and equals. Yeah. Save this file. Now go to your map class. Now create two student objects after line number 18. You can have student S1 equal to new student of with only one integer. And for both the students, try to give the same ID. So now you're creating another instance, but it's S2, but with the same ID value. Okay. Now input, just replace that with S1 and S2. Okay. Now try to print map1.size. Okay. Now execute it. So you got map1.size as 2. Okay. We'll do the same thing again. In the above structure, right? Map of integer of string. Instead of giving it as an input as direct int variable, create integer instance. Integer I1 equal to new integer of 1 and integer I2 equal to new integer of 1.
So it is taking it out.
No, it might be deprecated. No issues. You can still use. Just copy and have one more instance. I2 and replace I1 and 2 with I1 and I2. And both the keys, can you just have both as one key? Like similar key. Okay, now print the program, execute it. So what happened? The above program and the below program both are same. I have created two instances of integer with same values and I have inserted with same key and value. Only thing is I replace my key with object. Same thing I'm doing in the student object, but my map sizes is with 2 because it's a duplicate data. The S1 is also holding 1, S2 is also holding 1, and though both are having the similar values and my size is 2. But in the above structure, the same piece of code is returning the size of 1. Why is it so? Can you just
In
give
this,
control O in this class, in integer.class, give control O and see whether you have equals and hash code method here. So this
yeah,
is
yeah,
overloaded, right? So overridden, this method has been overridden. So what is happening in hash code? So they are having their own implementation for hash code. So what is the purpose of overriding your hash code and what is the purpose of not overriding the equals and hash code? That is the experiment we learned right now. So if you override them, the duplication will not be inserted into your map. So you will have unique set of data. The main purpose of your dictionary or anything is you'll have a unique input and wherever you want, you just go with search with of the key and you'll get the relevant value. If you have same key multiple times, it should be overridden, but it should not be creating new memory or new index positions or new node positions and linking them, right? It shouldn't happen. For that purpose only, we are overriding the hash code method and equals method. But now the question will be, what happens if I just override equals and not using the hash code? There might be a question like that. So what is happening? So now can you go to student.java, comment out your hash code and uncomment the equals. So right now I'm overriding only equals method and now execute the same class again and see whether my map.size is still 2 or is it having 1. Let's experiment that. I'm just overriding equals. I still see the size with 2. A duplication is still happening in the my student code. So now let's go and uncomment the hash code and comment the equals. I still see that with 2. So now uncomment both. So what happened? Right now it avoided the duplicacy and it was taking only the unique data set. So that is the reason, though you override equals or though you override only hash code, it will not end up with the accurate result set. Why is it so? Because the equals and hash code are interrelated because your hash code is something you're using whenever you want to insert your data in your array of bucket. If your hash code is not overridden, it will always create me the same bucket position or a different bucket position. Sorry, if you're not overriding, it will create me different bucket positions. Both S1 and S2 will be created in two different indexes in your bucket. And now if I just override equals, what happens? It will just compare the key and value and not the index position, right? It will just compare the keys and the values and not the position where your data is inserted. So that is the reason the equals and hash code together has to be overridden. If you're not overriding it, it will always end up with duplication. So are we clear on the equals and hash code contract?
Can you repeat that statement, Rooms? Like if we don't override the equals and if we
You just
override
noticed, right? Kiruba uncommented hash code once and uncommented equals once, and he uncommented both together once. So what happened when he commented either of the hash code or either of the equals method? What was your map size?
It is 2 actually.
It
It
is
is not
2.
considering
It is not considering.
two different
Why? Because your hash code method is used to create or to identify the index position of your bucket. To basically to insert your key value pair, you need an index
to
position.
get that index.
Yeah. So if you're not overriding it, what happens? Every time a new hash code gets generated. Right? Now, if I just override equals method, what happens? Equals method is used to compare your data and not to create or identify the index position, right? So even then what happens? Your data will be created in some other index position with the similar unique data. So a duplicate data gets created in another index position. Because the equals method will not help you to identify index. It will just help you to compare your data. So whenever you're trying to use get method, so that is something we'll see now again. Now, can you go to your map class? And in next is out after line number 26. Sys out. Use map 1 dot get off. Your key is S1, right? Pass S1. Same thing, do it after line number 18, passing map dot get off I1. Now, can you go to student.java and comment out your equals and hash code method? Now, execute this. So what happened here is, the first time when you're getting I1, you're still able to get the actual value of 1. Now, in the same line of 29, can you just print map1.get of S2 as well? You're still able to get the second input. If you even invoke I2, the data will be pointed to the same index position because there is an immutability concept. So the wrapper classes are internally, they are said to be immutable because the data, the value cannot be changed. So you can only know that by the size structure. So now can you go to the get method? You can give control click and go to get method. So if you see, this is again, so go to hashmap.class and open the get method. Like from your map class file, you have created hashmap, right? Yeah, go to the class and give here control O and see the get method. Yeah. So what is happening here? Every time you have obtained a key, we are going and searching the node. Can you go to that node method, get node? So here, there is nothing but the internal structure where you are having a relevant value or not, and where you are using the references. That is but nothing but your address position, right? So the references we use, and we identify whether that node returns the actual value which we're looking for, or it has to again do one more iteration. So here again, we are dependent on, if you see line number 568, we're dependent on hash of key. So every time we are getting a hash of key and we are comparing it and then going to the table and checking the relevant hash code, because your node has hash code, key, value, and next element. So you're dependent on hash code as well. So it will go and get the relevant hash code, and then only it will return the appropriate value for that particular key. So such uniqueness is being maintained in the backend to provide you the relevant value, avoiding the duplication. So in that case, if you are not considering the immutability concept for your own class or your customized class, then it will end up with duplicacy. So in that case, you can use list, right? Why are we in need of map collection? So map is something, it's like a dictionary. It has a unique key and the values can be unique or may not be unique, but the key has to be unique. So if you go for list, it will still store the list of values, but I don't have a purpose of like maintaining uniqueness in list. I can have any number of repeated data in my list, but in map, to avoid that purpose, we are having this kind of structure. The algorithm is like something where we are avoiding the duplication. Now, can you go back? Alt, you use Alt and back arrow. To go back, you can use Alt and back arrow.
But we gave same key only, right? Like one key
But
and
we
value.
didn't override, right?
Okay.
Right now, he has commented the student object, right? He didn't override the equals and hash code. Okay, to be more precise, we'll do that also. Can you give Alt and back arrow?
No, you said like map will be like you will contain only the unique keys, right? Actually, that's the reason we
See,
go
you
for
can
the
add
map.
duplication, okay? But the purpose of map is to provide only uniqueness. So if you're not aware of the uniqueness and if you're trying to give the same key and same value again and again, what happens in the backend is you're creating duplicate data in your map. Then what is the use of using map? You can use directly from list, right? That is also giving you duplicacy, right?
Yes, yeah, got it.
Yeah.
In that case, we will go for the map to avoid that.
Yeah, true. Exactly. So now, can you go to your map class, like the previous method where you use this get node method? Just give alt and
So-
back arrow.
Alt and back didn't work in this one.
It's not working. Okay, then just give. So if you see above map class, there are two arrows, right? Left and right. Above map class.
Okay, this one.
Yeah.
Okay.
The previous location where you were, it will help you to take there. Okay. So now what we'll do is do something. Yeah. Print the hash code of your S1, S2. You're not overriding anything here. So you should get a similar hash code since the data is same. But what is happening, we'll see. And do the same thing for I1 and I2.
So I1, I2 hash codes.
So I1 and I2 are having a similar hash code, and whereas your S1 and S2 are having a different hash code. Now, can you go to your student.java and override your hash code and equals method? The second map, yes. Yeah. So what happened here right now? You're able to see a similar value for S1 hash code and S2 hash code because the both are overridden with the logic of equals and hash code method. So you ended up with a unique data set, unique address. Though you have creating as two separate instance, the hash code is same. So their reference is always located to a similar place. So there is no duplicacy. So are we good till here?
Yeah.
Okay. So now let's do one more thing on the hash set. So similar to your hash map, the hash set also works. So the only difference is in your hash map, by default, your map gets created. Like in the back end, like the 16 index positions of your array gets created, and every time your node gets added. Now let's see how the hash set works. Just create set after that line, have set. So set is an interface. If you give control space after set, if you give control space, you can see that as an interface reference. That is also coming from util package. Yeah, enter. And this also expects similar to your array list. It is not key value, but it expects only the return type. So you can just give string right now. Create a reference equal to new and give control space. So you can give hash set and give control space. Yeah, use the first one, hash set. Now can you go to the hash set class? Control click and go to the hash set. Yeah. So if you see here internally, whenever you're calling a default constructor, what is happening here? You're creating a hash map, right? So you know the purpose of hash map. You know how internally the hash map will create an object for you and everything you know. But why this hash set is calling hash map is, but you are not passing any key value pair. You're just giving only unique data. So the main purpose of set is again uniqueness. So the linked list, array list, or any list interface will end up with duplications. Set hash map will come into uniqueness. So it will not take duplications. So internally, the hash set will also consider the architecture of hash map only. But how is it actually creating? So if you go to that hash, like if you see, like if you study the line number 103, it constructs a new empty set backing an instance which has an initial capacity of 16 and a load factor of 0.75. So which is nothing but every time you create a new object of hash set, it will create a new object of hash map which has the same array bucket from 0 to 15 indexes. And every time the data which you create as part of your set will internally store in form of map only. And the retrieval part also happens in the same way. So let's note that. Now can you go to your map class and add 2 elements into your set? The second file. Yeah. So in set 1, so the method which you use in your list, right, to add elements, the same is the set method you use here, add of, and you're going to pass some string value here. Okay. And create one more thing, set 1 dot add of, and pass some other unique data. And now create one more set and add the same data. No. Set 1 dot add of fed. Write the same thing again. Set 1 of add of fed. No. I don't want separate instance. I need to add a same element again in set 1. No, Kirba, I don't want this one. You just add, yeah, cool. So now print size of set 1. And execute it. You can comment out the above ones if you get confused. So though you have added 4 elements, it considered only 2 elements because internally the hash map will override your logic and it will avoid the duplications and it will print you the unique data only. So that is the reason we go with hash set or hash map. So why do we not use hash map directly and why we need set? So there might be places where you don't need keys, you just need the unique data. So what we do is we don't use the key and value pair. We just add the data to get the uniqueness. So for that purpose, we are using the set. Apart from that, the entire architecture and the algorithm part, which is happening behind, is only on the dictionary, which is map. So there is no difference explicitly. If you don't want key value pair, or if you want to iterate like your list and get the data easily, we'll use set. Or if you want a relevant key, say example, you might say like this particular student has been enrolled for 3 courses, and this each course will have a different pay and different course details and different duration. So you need to print the entire data set. Then you might go for map. But you're just going to say print only the list of students, unique students of each course. Then what you can go is, you can go map dot get of the particular course, get the list of students or set of students and print it. That's it. So you'll get the entire object set, which is a list or set, which is a unique data set. So we'll see few use cases how to convert from list to map, map to set, and set to list, and how we can do that. So are we good till here? So the set and map are mostly same. The architecture which we use behind the same thing. Only purpose is like, if you don't want key value pair in your business logic, we use hash set. If we need of key and value, then we'll go with map. But in the background also, the data gets inserted in your hash map structure only. So that is the major motto of this map internal structure. So equals hash code, hash map. So these are something like predominantly they'll ask in any interview questions or even in any program concepts. Sometimes they ask you to customize your own logic of hash map. So in that case, what you can do is, instead of writing the hash code logic and the equals of the system, you can override them. The second thing is, whenever your bucket array list is getting created, you can create your own bucket list. Instead of 16, you can have your own initial capacity. And you can write your own node logic where how your data wants. You want next address or you want previous address. You can customize that algorithm. So these type of programmatic questions will also come if you're trying to attend an interviews. So now for you, assignment is try to create list, array list, set and hash map, and insert some data in it, and print the data and see whether your data is coming in the same order you have printed, or the data is getting printed in a different order. So the basic concept tomorrow we'll be seeing is how we want to sort our data in the order we wanted. So right now, if you print your set, you'll get Jan and Feb as you inserted. But I don't want in Jan and Feb. I wanted to print that in the alphabetical order. So that in that case, I want Feb as my first input and Jan as my second output. So how that happens? How do we do that? So we'll be seeing 2 more interfaces, comparable and comparator interface, and how we can sort our data using that. And we'll also cover up few sorting algorithms over there. So are we good here? Just so try to make sure that you are familiar with this add method, put method, and also in the map. So we haven't seen how to traverse in the map and how to get the data. That will also we'll see tomorrow.
Okay.
Yeah. So are we good, Janaki and Kripa? Like, you have any questions or the concept is clear? Because it takes time to register, but the context is clear. You can just relook and get an idea.
Can we have some practice programs for tomorrow?
Yeah, tomorrow we'll be doing more of practice programs only.
Okay.
So we'll be trying few use cases and converting from the list to map and map to set. All these combinations we'll be trying tomorrow.
Okay.
So make sure, like, if you have any questions, ask me, because this is something, a major part in Java. Like, whatever program you work on, you'll be using collections. Without collections, there might not be any code. So make sure you are clear on these concepts, and we'll be working on few other use cases too tomorrow.
Okay.
Yeah.
Yeah.
Yeah. Thank you. Have a good day.
Thank you. Thank you.